Problem 1. Suppose that a particle moves along a curve with acceleration defined by a of t equals 18t minus 4. Find the equation of the position of s of t if the initial position starts at 5 meters and the velocity of 20 meters per second at t equals 2. So what we want to do is set a of t equals to 18t minus 4. We want to find velocity of t since it says find position as t. We know that acceleration of the integral is going to equal velocity, and velocity of the integral is going to go as position. So velocity of this would be the integral of a of t, which would be 18t squared over 2 minus 4t plus c. Let me make this a bit smaller. All this information. Small. Okay, there you go. We get v of t. There you go. Plus 4. We have v of 2 equals 18 or 9 of 2 squared minus 4 of 2 plus c equals 20. So we have 9 times 4 minus 8 plus c equals 20. And we have c equals 20 plus 8 minus 36. So c would equal negative 8. This makes v of 2, v of t equal to 9t squared minus 4t minus 8. Now we have to take the integral of this again. So let's take the integral of v of t, which is going to give us 9t cubed over 3 of t squared, 4t squared minus 8t plus c. Now, since v of t equals 3t cubed minus 2t squared minus 8t plus c, we get s of t equals s of t. Get s of t, which is f of 0 minus 0 minus 8, which equals 5, which means that the original function of s of t equals s of t 3t cubed minus 2t squared minus 8t plus 5, which is our final. Okay. Okay, so problem 2 says consider the function f of x equals x squared plus 4x minus 2. We got to provide the left-hand endpoint estimation of the area under the curve of f of x equals x at 6 and 4, and we want to know what L5 is. So we know this is going to be the definition function of f of x minus I of change of x, which is the same thing as 5i of f of 6 plus I minus 1 of 2 of 2. So let's make this a bit smaller since it's a bit too big. There we go. And we want to write this as 2, since we can factor out 2, as f of 6 plus f of 4, negative 4, plus f of negative 2, plus f of 0, plus f of 2. Which we have a change of 2, change the base is 2. And now we have to figure out what the values are, since all we have to do is plug all this into the proper function, which is this. So if we plug in 6 is 36 minus 24, which is going to give us 10. And the same thing, 2 plus negative 6 plus negative 2 plus 10, which is going to give us 2 of 10. Since 2 cancel out, and 6 and 10 cancel out, since this would be all 10, and that would be 10, and that all cancel out. So 2 times 10 equals 20, so we got 20. Now that will be our answer since for the left side. Now on the second part. Suppose the particle moves along a curve with acceleration. Oh, that's the same problem. This one. Suppose that the integral from 6 to 3 of f of x of dx equals 7. We also know that g of x is an odd function, and 6 to 3's g of x is negative. So how do we find this? We've got to find that f of 6 to 3 of 3 of f of x is the same as 6 to 3 as 1/2 of g of x. Since we know this is an odd function, and g of x is telling us that it is at -4, and odd means that when it's odd function like this, from here to here, all of this would equal 0. It will all cancel out. Therefore, we can say from the integral from 6 to 3 for g of x equals from 3 to -3 g of x is 0 plus 6 to 3 of g of x is -4. So we can say that this entire function will give us -4 times 1/2. And then this is 3 times 7, so this is 21, minus 2, so this will give us 23. Hopefully that helped. Now let's do problem 4. So this looks like the fundamental calculus part 1, meaning that we just plug in this into this. Since if we plug in 1, it'll cancel out. So this will just give us d over dx of the integral of x squared plus 1 of 5e to t minus root 4 plus t2 cubed dx dt. And this will just give us 5e to the x squared plus 1 of 2x minus 4 plus x squared plus 1 cubed of 2x. Since we have to add chain rule since there's another function inside of this function. Same things here. So this would be our answer. Okay, so for 5 we want to graph the function f of x. And we want to graph it using geometry and solve the area with geometry. So we know we want to have 4 as one of our bounds, so let me quickly sketch that out. That's one of our bounds, and -6 as our second bound. Boom, those are two of our bounds. Now, we want to graph this function now. We have plus 1, so we start with 1. Now let's go up 1 and then right 2. Up 1, right 2, up 1, right 2. And let's do that all across. And boom. We have our graph right there. And we want to complete the line right there and right there. Let me use a different color so we can represent the different area. There we go. As you can see, we have two different areas. And there. We can have two different areas right here. Let me just include this. And what we need to do right now is figure out where it's positive and where it's negative. I overestimated a bit right there. Right there. We have two different areas. We have the negative and the positive, the two triangles. I did this wrong. There we go, and there we go. So now we can see we have two triangles. One on the curve, one on the curve. So what we want to do right now is figure out what the arrows are going to be. For this is going to be 1, 2, base is 2. 2 times 1, 2, 3, 4. 4, this is 8, divided by 2, this is 4. So this area is 4. -4. Now we want to know the right side. So this is going to be 1, 2, 3, 4, 5, 6 times 3. 6 times 3 is 18, divided by 2 is 9. So we have -4 plus 9, which is going to give us 5. So this area is equal 5. Let's just write this here. Area equals -4 plus 9 equals 5. That's our one area. Now we want to find the area under the curve using integration. This just means using integrals. All we have to do is set up the integral from from 4 to negative 6 of f of x, which is equals to 4 to 6 of 1 half x plus 1 dx. So if we integrate this, it's going to give 1 half x squared all over 2 plus 1x of 4 to 6. If we write this carefully, this is going to give us 1 over 4 x squared plus x of 4 to negative 6. Now we just want to evaluate the integral. To do that, let me first make this smaller. Like that. And then let's integrate it. So from 1 over 4 of 6 squared plus 6 minus 4, 1 over 4 negative 6 squared plus negative 6. Okay, so this would give us 16 over 4 plus 4 minus 4, actually, plus 4 minus 36 over 4, negative 36 over 4, positive 6 over 34, minus 6. All this should give us 4 plus 4. Since 16 over 4 is 4 plus 4. Let me go over here and write a different color. 4 plus 4 minus 9 minus plus 6. And all this gives us 5. It confirms? Confirms. Now we just want to do something a third way, which is, okay, we're doing part C now. So for this, we want to find the exact area under with the definition of integral. So for this, we want to start with the limit of n approaching infinity from n to I equals 1 of 1 half x plus 1 on negative 6 to 4. So we want to know the change of x and xi. Change of x equals, let me change color so we can do this a bit over here. So I'm going to go b minus a over n, which is 10 over n, since this equals 4 plus 6, which is 10. And then for change of xi would be negative 6 plus 10 over n I, since this is a plus change of x of I. So it looks pretty simple. Okay, now we go back. Now we want to solve this, and how we solve this is we start integrating, or stop solving. So limit of x of n of I equals 1 of 1 half of negative 6. We substitute x for xi, negative 6 plus 10 over n of n plus n plus 1. And then change of x, which is 10 over n. Now we want to solve. Now we want to do the notation. So the limit of n approaching infinity of n I equals 1 of 1 half of negative 6 plus 10 over n I forgot I of n plus 1 over 2 plus 1 of 10 over n. Now we can distribute and then evaluate more. Of n of negative 3 plus 10 over n of n plus 1 over 2 plus 1 of 10 over n. So now we can see we have two values which we can apply the sum notation. So let's do that real quickly. Of negative 3n plus 10 over n over 2 plus n. Okay, since we have this, we can cancel up some terms, such as the n's for here. can cancel out. So this will leave us with this. The limit of n approaching infinity, and I have 3n plus 5 of 10 of n plus 1 over 2 plus n of 10 over n. Now I can distribute this function a bit further. However, let me make this size a bit smaller. Oopsie, let me make the text only. Just type. Sorry about this. Alright, we'll deal with this. That is not good. There we go. That should be fine for now, boy. So now I'll rewrite it. So we have this. So let me rewrite that. N plus 1 of 3n plus 10 over 2 of okay, we have this. Now we can easily cancel out and figure out what we have left. So the limit approaching infinity of n 1 of 3n plus 5 of n plus 1 over 2 plus n of 10 over n. And now can I make this smaller? Yes, I can. Okay, so we have this now. And then from this step, we can now multiply. So from the limit, when I push infinity, sin of negative 30 over n plus 50, n plus 50 over 2n plus 10n over n, and there we go. And from this, we can cancel out something, the n's, and then if we distribute this function a bit more, so it's 50n plus 50 all over 20 over n, 2n over 2n. We can get this a bit further. We can cancel out 10, we can cancel out 10, we can get 25, negative 30, plus 50 over 2n plus 10. Since once we take the limit of x function, the limit that n approaches infinity of this n goes to 0. So there we have negative 30 plus 25 plus 10. This would give us negative 5 plus 10, which would give us 5. And this gives us the correct answer as the ones above, 5, 5, and 5. Okay. Now, some trickier ones. Let's start with those. Value then the following indefinite integrals. Indefinite means we have to add the plus c. Okay, let's start. So for these, we can automatically just evaluate them without any necessary, but the most difficult part I see is this part. So that's what I'm going to distribute a bit more to partial fractions. So this is going to be x cubed over x plus 1 over x. So this can be simplified to x squared plus 1 over x. Boom, done. So if I rewrite this integral, it's going to be 4x squared minus x squared plus 1 over x minus 3e to the x dx. Now we can just evaluate it normally. So all of that just give us 4x to 7 over 7 minus 2 to the root 2 to the x to the 3 over 2 over 3 minus x cubed over cubed plus the natural log of absolute value of x minus 3e to the x plus c. And this would give us the full answer. Now, b. This, we just take the integral of it, which is cosine of x plus cotangent of x plus pi over x plus c. Now for c, if we do the same thing, but we have to do u sub. Let u equal 2x plus 3, du equals 2. So we have x of u cubed dx. However, we have an x variable, so we have to solve for x. So we have u equals 2x plus 3. U minus 3 equals 2x divided by 2. This equals x. Therefore, it's going to have the integral of u minus 3 over 2 times u to the cube du. Okay. Now all we have to do is solve. And to be able to solve this, we would like to do this. Let me just figure this out real quick. There we go. And yeah. Okay. And then to solve this, all we just have to do is just factor out 1/4 u minus 3 u cubed, and then now distribute this of u to the 4th minus 3 u cubed dx du, and then now evaluate it. U to the 5th of 5th minus 3 u4 over 4 plus c, and then now we just substitute all the variables back in. Which would be 1/4 of 2x plus 3 of 5 over 5 minus 3 of 2x plus 3 to the 4 over 4 plus c. And there we go. Okay, for the final one, we have to do d for this part. So we have to do let u equal tangent and du equals secant squared of x dx. And dx equals du over secant squared x. Now cosine of u of du, since if we want to plug in dx, du, secant cancel out, and yeah. And then all we have to do is just evaluate this. So it's going to be sine of u plus c, which is sine of tangent x plus c. Done. Alright, now we compute the definite integrals. So these look a bit more complex. However, they're pretty much the same, bit more algebraically, but all the same thing. So for this is 3x squared, 2 plus x. This would be 6 over 4, 6x, plus 1 over x, 4 to 1. And from this, we can just rewrite this as 3 of x to the negative 1/2, and then just add another 2 over 2. And then since this would give us 1 over 2, we have to do the copy dot flip, which will give us 3 times 2, which is 6 root 2x. Now all of this will give us is this. So we have to do 3 over 2 of 4 squared plus 6, 4 plus 1 over 4, which will give us 24 plus 1/4 plus 12. And now minus the same thing, but with 1, this will give us We can do this in our heads since it isn't too big of a numbers. 3 minus 6 minus 1. All of this should give us 29 plus 1/4 minus 3 over 2. It was 1/16 over 4 plus 1/4 minus 6 over 4. There we go. For B, same thing. Okay, this one's going to be pretty easy. It's just exponential. So all we have to do is let u du equals 16x dx. And then let u of 4, and then u of root 2. And then all we have to do is 16e to the u of x, or du over 16x. Since dx equals du over 16x, 16x cancel out, which gives us u of 4 of u of root 2, just e to the u of du. And then we just have to evaluate this, which is eu to the 128th of 16. So it's e 128 minus e to the 16th. And we cannot combine these since these have different powers. Okay, let's go with C. C is a bit more complex since we have to rewrite tangent, but it's pretty much the same. So it's going to be pi over 3, pi over 4, sine over cosine, dx. U equals cosine of x, du equals negative sine of x dx. And then du equals dx equals du over negative sine of x. And let's just also evaluate the bounds to u, since u of pi over 3 equals cosine of pi over 3 equals 1/2, and then u of pi over 4s equals cosine of pi over 4s, which is root 2 over 2. So when we write this, it's going to give us 1/2 of root 2 over 2. However, we need to change the bounds, so we need to add a negative of, let me write this first, sine x of u du negative sine, cancel, so negative. This will give us negative 1/2 root 2 over 2, 1/2, 1 over u of du, which is the natural log of u of root 2 over 2 of 1/2, which gives us the natural log of root 2 over 2 minus natural log of 1/2. Now the final one, d. D looks a bit hard, but it's pretty simple. We have to find the x, which is 3x plus 6 equals 0, which is x equals 2. Now we just have to rewrite the integral. 2, 3x plus 6 dx plus 4, 3x plus 6 x of 4, 2. Now we evaluate the integrals from 3x squared over 2 plus 6x of 2 to 2. Don't forget the absolute values. Absolute value, absolute value, absolute value, absolute value, absolute value. Does the same thing. Now we just have to do it. 3, 2, 2, 2. So this will give us this will give us 24 plus 6, which is 30. Okay. Now we want to do this one, the final one. Yes, final. So the following function represents velocity particle. We want to find where the positives or directions. Okay, so set up integral, displacement for 18 seconds, and then figure it out. Okay, so for this one, you want to set up integral. So here we go. So we have integral of 18 over 8 of v of t, which is going to give us area of 1 plus area of 2 plus area of 3 plus area of 4 plus area of 5 plus area of 6 plus area of 7. To find this area, we just have to go from here and figure out where the areas are going to be. And from what I can see are these areas. 1, 2, 3, 4, 5, 6, 7. Half circle, pi r squared over 2. Triangle, triangle. So triangle, base times height over 2. And then rectangle is base times height. And that's pretty much all we have to figure out. So for these, we're going to get 2 times 2. That's 4. This is going to be 4. Let me rewrite this with the correct values. Four, 6 times 2, 12. So this is going to be 4 as well. This is going to be 12, 6. Radius is going to be 3. So this is 9 pi over 2. This is 4. 1, 2, 3, 4. 4 times 2, 8. So 4. And this is 2. So all we have to do is add all these together, which is going to be 4 plus 12 plus 6 minus pi over 2 plus 4 minus 2, which gives us 28 minus 9 pi over 2. Okay. Now we have to set an expression. Set an integral total distance. Total distance, absolute value. So all this means is we have to just do the same thing that we did, however, with the absolute value. Since we know where all the zeros are, we just have to set all these with absolute value. So A1 dot 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 to A7. So since we know it's 4 plus 4 plus 12 plus 6 plus 9 pi 2 plus 4 plus 2, which is going to give us 32 plus 9 pi over 2. Thank you. Hopefully that helped.